Almost. Okay, a 40 Newton force pulls a 4 kilogram block along a horizontal distance of what? 8 meters. And the rope makes an angle of what? 35 degrees with what? The floor. And the coefficient of kinetic friction is given by 0.2. Then what is the work done by each acting on a block? Each force, in short, in this case, each forces we can edit using what? Each force acting, each forces, okay, each forces acting on what? A given object. Therefore, we can determine what? This one, using this one, each force acting on a block's man. Okay, the main target is that how many forces can applied on a given object. To understand, to solve such problems, first we must understand the concepts. There is force, okay? Force is a vector physical quantity, therefore direction is mandatory, yes? This force can apply to a given object, okay, right? At what angle? 35 degrees, whatever, above the ground. Normally, 35 degrees is an acute angle. There is an angle between what? 0 and 90 degrees. Therefore, it is above horizontal axis or x-axis, or from floors. Therefore, we must physical diagrams, for this one. Okay, let us draw the physical diagram for such a questions. Okay, in this case, it must be what? A diagram can be necessary. And this, let us consider this one is what? A horizontal floor, we can say floor. And there is a force, there is an object which is placed on this one, an object which is placed in this case can be, let us consider the object is placed this one, this horizontally, and there is a force applied which is an angle theta. Therefore, we must draw this one. There is an angle theta. This one is a force P. Let us represent P, or we can represent an arrow since this one is a vector. Therefore, we must represent vector since force is vector physical quantity. And it is the angle between this one is 35 degrees. There is an angle which is 35. Okay, 35 degrees. Okay, this is an angle which is 35 degree. Okay, 35 degree. There is 35 degree. 35 degree. That's given. There is another forces, and which is normal force. It is also a vector. In this what? Vector force. Therefore, this is a vector. Therefore, it must be what? In each direction. There is another forces, natural forces, which is downward forces. There is downward forces. This is downward forces which perpendicular to the surface. And there is another forces which is generated by what? The roughness of the surfaces. The roughness of the surfaces, which is opposed to the motion of an object. For this one is frictional forces. Therefore, let us represent this this one. Let us P. Let us represent P force, and there is what? This one is N forces. Okay, normal force, and there is what? This is frictional forces. So I mean the weight of an object, and this one is frictional forces. We can say frictional force F. Look at after that, it must be this force is two-dimensional forces. This is the mathematical expressions. This is what you called. This statement can be expressed by this one. An angle theta is what? 35 degrees. There is P is 40 newtons, and it's all there is displacement D. displacement baby part moved in this displacement is. For another quantity is that we have given is a displacement. There is another displacement given there is a displacement s. Let us s is equals to what? 8 Newton. Is 8 Newton, I mean meter, and also an angle theta. Angle is equals to what? 35. And another given quantity is P, which is a force applied, which is given by 40 Newton. And also there is another given, which is the coefficient of kinetic friction. Coefficient of what? Kinetic friction. Coefficient of kinetic friction, which is given by 0.2. This is the given quantity. Also mass. Another mass is M, which is given by 4 kilogram. Okay, 4 kilogram. Then after we must resolve P has also there is P cos theta, and also there is P cos theta. We can say this is normal force, which is equals to Px. Let us represent Px is equals to, that is 40 Newton times Newton. We can say Newton. That is Px, which is cos theta. Yes, cos theta, which is cos 35 degree, and also another Px. That is what? Px, Py, sorry. Is what? Py is equals to, also 40 using trigonometric function, 40 Newton times what? 40 Newton times sine of 35 degree. This is the given physical quantity. Then the required, which is required is what? Work done by frictional force, by frictional forces. How much? Is equals to how much? The same work done by P. Work done by P, sorry. Work done by P, how much? And the third one is work done by P is equals 0. Work done by normal force N, which is equals to how much? The same work done by gravitational force. Work done by gravity. Work done by gravity. How much? This is the required. Then there is what? This is given. Okay, there is a required, such as required this. Then when it comes to solution, okay, solution, which is work done is equal. So general formula, that is work done is equal to F, that is S cos theta, that is 35 degree, if you can say. Therefore, work done by Py. In this case, this implies that work done by P, which is given by, that is 40 Newton, which is Newton cos theta, that is times cos theta, we can say cos 35 degree times the displacement x is 8 meters. This is okay, is equals to how much? 200, I think so, 262, I think so, 62 joules, which is work joule. But but the work done by the work done by gravity, which is weight of an object, and normal force, and normal work done by normal force, normal force will be zero, will be zero, will be zero, since the angle between what? The force, the F or P. You can say P and S is right angle, okay? Right, let us. This is what we call it. And there is what another one is. In this case, you can see there is horizontal components. P has two components, that is, which is drawn by this one. There is what vertical component. Vertical components of such phenomena can be drawn by. This is Px, I mean Py, and there's what this is what Px. This one is Px, is okay. Px. This is Px, and this is Py. Therefore, this component doesn't have what? The work doesn't work. That is, this implies that the vertical component of P doesn't do what? Doesn't involve also work done, or we can express the work done by the work done by the vertical component of P is zero. The same is zero, since the angle is 90 degrees, or right angle, okay. And the other one is okay, and this one is what the vertical force will be zeros. Therefore, this is what we, and also the other one is a frictional force. There is a frictional forces can be expressed by 90 degrees. Also, F is, we can say, frictional force. Work done. The work done by frictional force is also given by F cos theta. F, that is F times S cos theta. S cos theta. That's the cos theta. Theta is 180. 180 degrees. This indicates that 180 degrees, here's what, given by what? 180 degrees. And also this is equals to normal force, which is mg, which is equals to normal force means mg times the mu, is coefficient of what? Mg cos theta, mg cos theta, but 90 degree, 0 degree, that is 90 degree cos theta. Mg is times x, is x, that's s displacements, s times what? Coefficient of what? Coefficient of what? Kinetic friction. This is equal to mg is, which is 4 kilogram times mg, that is 10, let us given 10 kilogram times meter per second square. Okay, times the same, this what displacement is 8 meter times what? The another parameter is cos theta, which is cos 180, which is minus 1, okay? Minus 1, which is given by minus 1. Therefore, the value would be, this is equal to, that is IT 300 minus 300 joules. This is what you call. Therefore, we can determine the frictional forces. Work done by this ones can be only done by the vertical. I mean, as a horizontal components, the vertical component will be 0. Okay, today it is enough. Thank you.